One live. So the stream might be in 360p. I don't really know what's going on with that, but we're just gonna roll with it because OBS is being weird. Fill out attendance, I guess, so we know people are here. And Chris, do you have the questions thing up?
Yeah.
Good. Okay, the upcoming agenda tomorrow is GUI development and programming club. So I think they're talking about ncurses, which is still like in command line, OpenCL, and Love 2D, right? For programming club.
What?
All right, good talk. So it's ncurses.
Okay, keep going.
It's ncurses, OpenCL, and Love 2D.
Yeah. Oh, yeah. OpenGL.
OpenGL. Oh yeah, duh.
Really close.
Just one letter. It's rough. I can't spell anyway, so it doesn't matter. Computer Club, they're doing editors, so they'll be talking about probably like Nano and Vim, and maybe they'll bring up Emacs and how to close it, because it's bad. DefSec is mini-mock next week, and we're going to be trying to do lock picking next week. Tyler doesn't think we can do it, but we're going to prove him wrong. So, Tech Fun Day is this Saturday. We're actually going to be running some of the events in the Hexathlon. That's what it's called, right? Hexathlon?
Yes.
So, yeah, you just like, it's meant to be possible for any freshman to do it, as well as like still fun for upperclassmen. So it should be like in reach of everyone, even if you're like, I don't know Python, like you might get a little introduction to it and kind of learn it. I don't know what's going on with the games and puzzles stuff, but it'll be there. And then mini hackathon, he's currently planning, because this is like Tom's planning it, 10 a.m. to 8 p.m. I'm not sure which events span like what stretch. But
So it's going to be a programming contest and maybe code golf
And logic questions.
and logic questions.
So it's a good time. Everyone who's here should try and be there at least for a little bit. There's the sign up. There's the long form link that Tom gave us, and then DefSec shortened it, so it's like not awful. MLH build event. This is more of the you hack something together, you present it, you can win some prizes. So there's still a bit of time. I think, is that the last week of normal class? So it's
Yeah.
like before finals. So kind of a way to just like mess around, play around with some cool stuff, learn a bit. Should be a good time. Now there's also the long form mock where it's like Ice Age and Cyberforce. That opened up like a few hours ago, I want to say, where they assign teams, but at this point, if you still want to do it, you can probably message at NIC on Slack. Probably still get in, because I think there's only 3 teams for it now. But you get time to like prep your machines way beforehand, way before Red Team gets access, so you aren't like worrying like, oh, they've already got shells on me. Though stuff is probably backdoored a bit. So sign up link is there. It's also probably in OffSec, I think we posted at one point, and DefSec channels too. Current events for Greece.
Oh my gosh.
Got like maybe 10.
Oh, this is weird. I can hear myself too. Oh, so this one was really fun. So Facebook for like iPhones, there's a nice little glitch where your camera's activated when you're watching videos and like scrolling through your feed. So what the researchers aren't sure of right now, and I actually don't know if it was an actual researcher or if it was just some random dude on Twitter that found it, but they're not sure if this is like a Facebook built-in feature that they're actually like creeping on you through your camera without your knowledge, or if it's actually just like a bug. So that's something to keep your eye on in the news if you're interested in that.
So,
But
so just get rid of Facebook and you'll be good.
yeah, but this is an example of someone getting it to work, and it works on the updated version, but not like iOS 12. So like the fully updated one, and they looks like you're just able to do it by like pulling down on the video after he opens it. It's just weird. This one's really cool. So if you haven't heard of like Spectre and Meltdown, there were kind of some like neat side channel attacks that kind of attack what's called like speculative. There's another word in there. What was that?
Speculative execution.
Shh. sure. Yeah. Well, I'm just gonna call it speculative execution. So, kind of how it works in like an overview of it, because it's pretty in depth. Your computer, in order to be faster, will do predictive processing. So things that it thinks it will need to process in the future, it'll actually process those, and then be like, oh, I already have the result for that. So it's the way that they're trying to make things faster. But there have been Spectre, Meltdown. There's another one that was like Future or something. And now there's this one, which it works on like the new ones. So like the new processors, it works on these. And doesn't work. It's been patched in like Xenon and like the older processors. So if you have those, you're fine. But like some of this stuff is kind of fun. Yeah, that's all I'll say about that one. It's cool. You can do like register snooping, so you can see stuff that you're not supposed to see. So you might be able to grab like passwords or hashes just from things being processed. But you kind of have to have access initially in order to be able to do that. So, and then I just threw this one in here also because this is some research that popped out. So it's been known for a while that you can mess with microphones with lasers, and it's just by like modulating the power that you put out with the laser. So being in the same frequency like the human voice, you can copy what can be interpreted as like human speech as far as like what you're pushing frequency wise. So using that, they were able to, from a distance, like activate Amazon Echoes and like Google devices. So this is actually just like a video of them hitting it from like 110 feet away, I think. So it'll show like this, and then here's the laser down at the hallway, and like the speech that they're sending to it through the laser. There's the device that they're sending it to. So where they think that this could be used effectively, if like you set your device in the window, they could even use like infrared to hit it without you knowing. It's just they didn't test that at a big distance because they don't want to like blind people, which is probably good. But they did it all the way up to like 165 feet. They were able to activate, I think Google Home devices up to that, and then some Android phones were able to be activated up to like 30, and iPhone was like 16 feet, I think, something like that. But it was a decent range for like activating Siri still, and then like doing all of that. But one of the other tests that they did, the one that was like 165 feet, they were on a completely different building, like on the roof, and they shot the laser through someone's window. They just had the device like sitting right there, and they were able to activate it. So like people that have like voice purchasing turned on for their devices, or something along those lines, so you could attack them in that way, I guess. Or you could like schedule weird reminders, like telling people that they're ostriches at like 2 in the morning or something. But, yeah, funky stuff. Logan's turn.
Okay, so for tonight, we're going to go over PWNTools. For those of you who don't know what that is, it's a Python library. So who here's actually worked with Python before? All right, so that's a couple, not too many. These right here, these are Pythons. It's a green guy. Don't get close to those. So this is how you use libraries in Python. I don't think blah blah is an actual Python library, but Python libraries are pretty much the same thing that C libraries are. When you import something in C or include something in C, it's the same as like importing something in Python, pretty much. You can have classes, functions, variables, all of the other stuff that you need to use from that library. PWNTools is mostly kind of directed towards CTF kind of stuff, so like pwning stuff, as in the title. But here I'm going to show you some other stuff you can do with it. You can run processes, you can SSH in, you can netcat, all the good stuff. So here's an example of SSHing. So PWNTools has a module just to SSH in, so like you don't have to load in Python's other SSH library and then do a bunch of other stuff to get a connection going. You can just straight up run SSH, give the user, give the IP, and then give a password. From inside this, you can like do whatever you want. You can download, you can upload, you can get a shell, you can run processes from this SSH connection. So like this right here would be something we'd use during a mock competition just to like loop through everyone. On the Linux side is that let's see if we can SSH in as DSU at their IP, and we'll just make it a little range or something. We'll give them a file. We'll download the password file. We'll upload our key. Yeah. So that's SSH. So it also does remote connections. Like if there's a netcat listener listening or other program listening to a different port, you can just connect straight to that port. So like at this one, we're connecting to 1.15 at port 1337, and then I'm able to send in whatever I want. I can read until whatever I want. I can just interact with it if I need to. So like this is useful for CTF challenges, as I've kind of said earlier, but I've also used this for like telnet connections where I have to send in specific commands to telnet. So I can just go in through there, and then that's a little bit more complicated, I guess. You can also start up listeners in local processors. So like right here, I want to run bin.sh. Bin.sh on my local machine. I can just say run as a process. I can send in whatever commands I want, also interact with it. Otherwise, I can also just listen for a process and then interact with it. So like if I have a remote shell on someone else's system, I want to have a netcat listener coming back, I can just say, hey, listen on port 1234, and then interact with it once it actually gets a connection. So here's some more like advanced stuff, but it's also useful. So like whenever you have to send in specific bytes into like to exploit a program, you usually have to pack it because of the way data is stored. It's like little endian. So like the characters are actually stored backwards in data. So like that's where packing comes in play. So regularly you have to like import struct and then pack it with a character. So like I stands for integer or something, and give it a little less than or greater than, depending on what direction you want. This kind of gets tedious, so I just prefer just to say P32. I want to pack it as a 32-bit program. I also do have P64. Inside this, there's also like side options to say I want it, what endianness it is. So like if it's not little endian, you can also just make it go big endian, which no one does. There's also some useful assembly. So it can actually like run assembly commands or print out assembly commands for you. So like if you said, give me the assembly of move AL0, it'll just print out the byte code of it. So it'll be like, I don't actually know what that is, but we can try it. Little side tangent. So let's import everything. Just print asm of move AX0. Whoops. So yeah, as you can see, there's my bytes. Not as readable as you probably thought. But anyways, you can also just make an elf file. So like if you have some shell code but don't actually have a way to run it, you can just say, hey, make an elf out of this string, and then it'll make it, and you can just run it straight from there, I didn't know that until recently actually, which is pretty cool. There's also a way to encode if you make some shell code, there's a way to encode it. So it's like, hey, here's my shell code. Fix it so it doesn't include new lines or white space, because that can actually ruin it if you're trying to input it to something. So yeah. It also helps with ROP. So does anyone not know what ROP is? Okay, well, ROP is return-oriented programming. So you kind of just take control of the program, and you have to make it jump around to wherever you want to actually run commands. So like to do that, you actually have to make a ROP chain. So PWNTools has a useful feature for that. So you can load an elf or a library, whatever. So like here I'm just loading bash, and then inside it I just want to find like where execve is. So I can say, hey, give me the location execve, and then just push it straight to the stack or onto my ROP chain. So like right here you can see that I'm putting 0 onto it, and then I'm also putting execve. So right here we have if that goes away, we have 0, and then we also have the location of where execve is. So then from this you can also just find the base address and stuff. It's pretty useful and helps you not have to use other stuff, I guess. Jump around. So it also does for GDB. So like if you're running a program and it keeps crashing after you send in, so like you have to send in 20 lines of commands before it actually crashes. You can do this where you can start your process, run your 20 lines, and then attach your GDB session to it, and then actually walk through this next command you want to send in. This helps you like determine what's actually crashing or what's in a certain register. Helps with debugging or getting the right execution to persist. So that was kind of quick, so I'll kind of do an example. So at pwnable.kr, which is this Korean wargaming site, there's a challenge called input that we're going to go over. If you actually go to the home page, oh, not that one. That's a different one. If you go to this home page, there's actually a little video about an exploit used in Mario, which you can actually, people have actually done in real time without like needing a decompiler, but it's actually pretty cool that they make sprites be in a specific position to exploit the game to just jump straight to the end. I'd show that here, but it's like 10 minutes, so it's pretty cool. So if we look at input, all it says is that, Mom, how can I pass my input to a computer program? And it gives us some SSH creds. So if we SSH in there, go in as password guess. Oh, guessed. There we go. We can see that we have a couple different files. So if we just tried to read the flag, it shouldn't let us. So we don't have permissions. As we can see, we can only read it as input 2 and as root. But we do see that we have two more files. We have this input, which if we look at it, we can see that it's just an ELF executable, and that it also has set UID bit. So like if you run it, you're going to run it as this character. So we will be able to read it if we run that. We can also see what most likely is the source code. So if we pull this source code to our local machines, we can start working on it. I already have it downloaded, so don't actually need that page anymore. Oh. Whoops. There we go. If we look at this, we can see that it's, here, let's just run it also. So it says, welcome to Pwnable KR. Let's see if you know how to give the program some input. Just give me the correct inputs, then you'll get the flag. So seems easy enough. So if we start from the top, we can see that it's asking for argv arguments. So first it says argc has to equal 100, which means we have to send in 100 arguments. So if we start with this file, we can say with process to run a local process as p.interactive. This will just run it pretty much the exact same as running on the command line. So that doesn't actually help us at the moment. Oh, it's called a.out. Yep, so right here it's just the exact same, and then it dies because we got it said we know it dies because we got the EOF. So what we need to do is actually send in a 100 arguments. So the way to do that in PWNTools is to just make a list. We'll just make a list of 100. We'll set the list at index 0, the name of our binary. And then this way it'll give us our 100 arguments. And you just send that list straight in. So right there we're sending in 100 arguments. So argc will equal 100. But if we keep looking, we can see that argv at character A has to equal a null byte. So we can also set that. So add 0x41 is equal to the null byte. And then the next one says that the character at B is also something. So 42 is equal to 20, 0A, 0D. So if you guys don't realize, 0A is a null byte, which means it ends like any kind of string that's being sent. So like these kind of inputs would be hard to send into on bash just normally, because 20 is a space. So like how would you send in an argument with a space? And then it also has a new line and a carriage return. So just trying to send in those is kind of difficult in bash. So we'll do it this way. So if we run our program, we can see that we did pass stage 1. So now if we go into stage 2, the first thing it's asking, or does, is that it creates this character array and then reads 4 characters into that character array. 0 stands for standard input, so it just means we have to send it in through the command line. So we can do that, p.sendLine 0, 0a, 0, 0xff. See, these are also harder characters to send in because you can't just send in most of these characters regularly in the command line. You can't send in a no byte, can't send in 0xFF with your keyboard. I just throw our ways, but now we go on to this one. This one's a little bit tougher. I remember the first time we did this, we actually got stuck at this part because I don't even know if I knew what standard error was at that point, but whatever. So this is saying we're going to read from file descriptor 2 into buff, and then we're going to read 4 characters. So file descriptor 2 is actually standard error. We have standard in, standard out, and then standard error. So which means if something like breaks in a program, usually data gets sent here. So like we have to try and figure out a way to actually send data in there. So as far as I could tell, there's actually no good way to do that in PWNTools. So we're actually going to have to create a system-based kind of pipe to overwrite it. So standard error read and standard error write. Oops. We're going to call os.pipe. This will create a pipe for us where it returns a tuple of our standard error and our standard write. So if we have that, then we can say os.write to standard error write. And we're going to send in the characters 0, 0A, 02, and FF. And then down here, to tell the process that, hey, standard error is now at this pipe, we're going to say just standard error is now equal to standard error.read, or just read. So if we go through this, oh, got to spell right correctly. I got to spell something else now. There we go. We can see we now have stage 2 complete. Thank you, Chris. That was a toughie. So next, it's checking the environment variables. So does anyone not know what an environment variable is? All right, well, so if you were to do env, these are the environment variables in bash that I have running right now. So you can see that my shell is bash, got some other garbage that I don't really care about. But which means this program is going to go into my environment variables, grab this guy, which is dead beef, and then check for Cafe Babe to be at that location. So let's just create it. We'll create a dictionary. For those that don't know what a dictionary is Python's kind of like a directed array. So like you can say A is equal to B. So like if I wanted to print the variable at character A, I can now, it'll print out B. So it's kind of just a way to keep track of some data. Whoops. So if we create this character or this environment variable dead beef, F, and set it equal to Cafe Babe. And then we can kind of send it in just the exact same way as we did at the standard error. And we can see we now have stage 3 cleared. So now we're getting somewhere. So this next one, it wants to open a file that's called newline. As far as I know, you can't just say, hey, whoa, touch my file that's newline. Yeah, that's not what I wanted. So, but Python doesn't really care about any of that. And this isn't just PWNTools, it's just Python. So we can say with open, it's open newline as writable. Say as fp, fp.write. Oh, it's writing 4 null bytes. So we'll do that. I didn't really explain this, but with like this statement right here is pretty much the same as just saying fp is equal to open, blah, blah, blah. And then saying after saying fp.close. See, what with does is just closes it automatically once it's outside the scope. So I think it's just an easier way to do stuff. So right here, if we write 4 null bytes to our file that's called newline, that should give us stage 4. Yep. And now if you actually look at what it looks like, this is what a file that's newline looks like. It's kind of gross. But that's, and it's kind of impossible to delete it now, but we'll not worry about that. So, last one. It says network right here, so we have an idea of what we need to do. So if you haven't actually worked with networking with C, it's kind of gross. You have to do all these commands to open up a socket and then set the socket to a specific port, which it looks like it's setting it to the number at variable or at location C in our arguments again. So go back there. Then if it does, it'll listen there and then pretty much just receive it, because that's the more gross stuff that's for it. So right here, we're just receiving 4 bytes and then comparing those 4 bytes to dead beef again. So as I can do, we can do another just with, say remote, we'll say localhost, and then say port 1234, so we should probably specify what port we're actually going to do this on. X43, 234. So we'll connect to localhost on port 1234, and just r.send line, send dead beef. That should be good, I think. Here, let's echo test 2 flag, just to be sure. So as we can see, we actually cleared all 5 and then got the test inside there. So we're not done yet. We got this working locally, but we actually had to get it working not locally now. So this can be another confusing part. So if we SSH back in there, which I don't have in that one. There we go, guest. So as we can see right here, if we actually try to say, like if I were to copy and paste and just say my file and then just did it to input.py, we actually don't have permission to write inside this directory, which kind of messes us up a little bit. But if we change to temp, we can't actually read this directory either, but we can make stuff. So if we make ABCD, looks like it's already there. So if we change to ABCD and looked at it, we can see that someone else's exploit's actually there, but so we don't care about that. But what we'll do is we'll come into temp, put our file and stuff there, and then get it to run. So what I'm going to do is make an upload script. So, and I'm only doing this because I'm not skilled enough to actually get to work all in one file. Yeah, I know, I'm a failure. So SSH into here as the user input 2 into pwnable.kr on port 2222 with the password guest as S. And then we'll do an s.upload. Do it. Oh no, we should probably do this first. S or t equals s.show. So let's actually make sure we have a file to store it at first. So we'll go t.sendLine. Line. We'll rm any directory that's already in our spot. So go temp at .hex. And then we'll make that directory temp.hex t.sendLine. I think that's all we need for now. Yeah. So I'm actually going to also import from time import sleep. So since this is a remote connection and PWNTools doesn't actually care how long this takes, like it'll send the command and then move on to the next command. So if our command is actually, so far like this command right here is expecting the hex directory to already be there, it might not have been made yet, so it can break stuff. So we'll just give it a little sleep to tell it to wait until it's done. And we can do s.upload to upload our input.py to /temp/.hex. And let's see, do we need anything else? I think that's it. So we can do t.interactive, run Python upload. Oh, didn't like something. Input to that just says failure. Let's try that again. Okay, so doesn't like that. Maybe we need to specify the file too. There we go. Okay. So if we change to our .hacks, we can see that our input file is not here. So if we were to run this, we'd have problems because currently it has our process running as a.out, which is not the case anymore. So I need to find where that is, change that to, all right, so this will just be easier to do on my local machine. Input.py. So we'll change this to /home/input2/input. So if I were to do this and go through it all, there'd be one more problem, is that if we look at input.c, right here it's trying to open the flag that's in the current directory. So if we move to our temp directory and then ran that, it wouldn't work because our flag isn't actually there. So what we're going to do is actually make just a symbolic link in our upload file. So we'll send one more line. Say temp, no, home, is it local or, I totally forgot again. So local first and then remote? Okay. So I'll put a file here called flag and then reference home/input/ other way? All right, we'll say at home/input2/flag and then put that right here at flag. If you don't know what symbolic link is, that's just saying I'll have a file here, but it's actually pointing to a different location. Failed to create, file exists. Did it work? Did not work. Oh, no, I'm in the wrong spot. Oh, that's why. Okay. Did not work because it's technically still in its home, so we have to specify .hacks. So yeah, a symbol.
You need a slash before it.
Okay. One more try. I guess I could have just done this in the command line while I was there, but let's make it harder. There we go. So if we change to .hacks, we can see right here that flag is actually pointing to this guy. So if we try to read it, we still can't because we don't have permissions. But if we ran input, oh, who put that little dot there? Let's see if we can get rid of it. Oh. Let's see if that worked. It did not. What is going on? Oh my gosh. So, it's nice that you guys were able to point that out ahead of time and save us all this pain, but you just want to see me cause problems, don't you? Temp.hacks. So if we do Python input, we can see here we passed all 5 and then also did mommy, I learned how to pass various input in Linux, which is one of the weirdest flags ever. But if you start working on this page, you'll see, I gotta log in first. I don't think it's gonna matter because I already have it done, but if you do these, there's a lot of kind of creepy flags. Then boom, you already have authenticated this flag. So yeah, that was input. There's a lot of different challenges here. Like once they get here, they get hard because you can't cheat. As in, all these first 2 sections, there's write-ups all over online because they don't care. Or they say they want people to have write-ups from, but once you get down here, it's like, shush, shush. It's like if you look at this one, only 76 people have gotten it. But if you look up here at file descriptor, 25,000. So they get difficult pretty fast, but they're a great learning opportunity. That was kind of all I had planned, but if we want, I could also do a buffer overflow one. Yeah.
We wanted to know more about Rob.
Okay, what do they want to know?
I don't know. But more. Yeah.
All right, so let's see. I got an idea. So if I were to GDB this a.out file, start it up. This will bring me to main. And if I X16, so in assembly, there's instructions called returns, I guess. Or how assembly works, pretty much, is that there's a stack. So like you'll push on variables and stuff onto the stack. So if we were to dump our stack right now, we can see that we have this memory address, which is another stack variable, 0, stack, memory, garbage, I don't know. But anyways, so what wrapping is that so if we were to actually, this guy right here, if we looked at him, we can see that it's actually inside this guy, this initialization function, which is called right before main in the back. So when it returns, it'll actually return to this, and which is why the return address is on the stack. So I'm kind of saying this poorly, but the stack holds the return addresses. So if you can overwrite these return addresses to say, do I have wrapper? I do. Awesome. If I could say overwrite the return address to this guy and then have the next value on the stack, I now control RBP. And if I do it to this guy, I now control RDI. So wrapping is kind of just a way to control the registers, because if you can control the registers in the control flow the correct way, you can gain control of the whole system. So yeah. So like if I wanted to call printf or something, what some people don't know is that, is there a printf in here? There should be. Oh, there's puts. Those aren't the same. Oh well. With printf, if the register RAX is not equal to 0, printf will have some crazy behaviors or might not work at all. So like if we're just able to control different registers, we're able to control the different kind of input that goes to a function. So it might allow us to print something, might allow us to control something, might give us a shell. So it's kind of wrapping at a high level. Any other questions? Okay, well, you guys want to see another one, or was that too much? Do I need to go over anything again? Another? Okay, I kind of practiced BOF, but are there any here that we just want to jump into that I haven't touched in like 2 years? That we can just...
Third section.
Which one?
Third section.
Third section?
One there, yeah. Yep, there.
Okay, so command 3.
Okay.
I need the password command 2.
Okay, just start with it.
Alright, so I need to go to command 2.
I think you just skip straight to the bottom.
Which one?
Just skip straight to the bottom.
Oh, the bottom?
Yeah, do that. Yeah, your CJ.
Okay. That looks like memory stuff. That looks gross. Calculators, that looks hard. Oh, tiny. This one's actually good. I think I know how to do this one now. I've looked at this one a lot. That's not true. Oh, is it not guessed? There it is. Okay. So, can we get the flag? So if we run tiny, okay, segmentation fault. If we open it up in GDB, oh, that's not going to work. If we object dump it though, is it tac s? D? No, it's lowercase d.
What are you trying to do?
I'll just dump it all, or just dump D and then M into.
Yeah, it's
Okay, well, I'm going to make this relate to PWNTools. So we'll say vim download .py. It probably does, but this is PWNTools today. And I'm not actually sure in the syntax for SCP.
Yeah.
Oh, you got me? Okay. SCP.
Space. And then. So the IP and then port. So.
Pwnable.kr-p of 22 still? Yeah. 222.
Specify a user.
Probably.
Yeah, just do like user at pwnable.kr.
How do you specify your ports? It's the same way.
So
Okay.
And then right after the, yeah, so do like yep, and then do like the home directory thingy / yep, Yep, and then the file.
Tiny.
Yeah, and then
You need a dot at the end to specify where you want to save it.
You do your tech P before the tiny app.
it's like harder to voice functions.
You guys said you knew the syntax. Oh. So it's obviously not dash P. Capital P. Password is guest. Okay. So don't tell anyone I showed you this because.
It's totally not being live streamed.
Oh crap, you're right. We're not supposed to show walkthroughs of these. But anyways. I'm gonna need to
Yeah, it isn't super good.
copy Tiny to my shared directory. So we're just gonna actually toss this guy into IDA, see what we're looking with, because it's okay. So if we look at it, it's actually only 122 bytes, which causes problems with GDB. I can try to run with GDB. File.tiny. Okay, I don't think I can just break it start. Oh, it did work. Okay, sweet. Let's print out 100 instructions from RIP. Can't be an integer. Oh, no. Oh, it's 32-bit. Okay. EIP. Oh yeah. As we can see, we have a bunch of zeros. This is what. Oh gosh. So we have 4 instructions. We pop EAX. We pop EDX. We move EDX into EDX, and then we call EDX. So, where to start with this? So let's see. If we try to run it with some arguments, do we get control? Pop EAX, so EAX controls 2, so EAX is the argc. Pop EDX, EDX now controls my argv. Oh, okay. Oh, sorry guys, I can't show it. This is too easy. Yeah, this isn't too bad. Okay, unless we don't have, oh yeah. Oh, NX is enabled. Makes it a little bit tougher. Huh. Now I'm kind of confused. So my first thought was, since we can control EDX, it's not well known, but argv1 or argv0 doesn't have to be your program's name. There's actually a way to influence that where it can be argv2 or argv1. So that'd be the way to control EDX, to jump wherever we want. But now our current problem is that since NX is enabled, which it might not be, I don't know how to test that. But since NX is enabled, we can't just run stuff on the stack. But we can jump wherever we want. So we could jump back here. And if we control EAX and EDP, let's see, what kind of wrap gadgets do we have? Oh. Start wrapper. Wow, it's too small to get a wrap gadget. Okay. Well, this doesn't seem right though, because VM map, our file was 122 bytes, but if we look at these instructions, that's only 6 instructions worth of stuff, so there's got to be more that we're missing. So if we look at our base address, x/6, let's go 100gx. We get a couple right there, a couple right there, but yeah, nothing looks good. Actually, this might be x/iv. So we have this push ECX 4, which isn't anything. And in is a kind of just a port manipulation. Yeah, this is garbage. Oh yeah. But yes, that was a hard challenge. But at the moment, I have no idea what to do with this actually. Any ideas? So we can control one register. We can control where we call to, but we can't really write to anything except for the stack, but the stack kind of changes. There's an earlier tiny also, which is a lot easier. I could do that one. Whoops. Tiny. Tiny hard. Oh, there's another tiny. Look at that. There's a harder tiny than tiny. But if we go to tiny easy, I remember this one. Okay. So it says I made a pretty difficult poem task. However, I also made a dumb rookie mistake and made it too easy. So if we SSH in there. So I think I spent like 5 hours on this one because I was like, what is it? I've never seen something like this before. So if we look at the length of tiny, there it is. It's even shorter, it's 90 bytes, which is probably the same size as tiny hard. So I'm guessing those two are the exact same. But if we look at this guy and just cap the flag, I thought that'd actually work. What did he make too easy? Maybe it was, do we have check sec? We do. Oh, NX is disabled. Okay, so you probably just hop straight to your shellcode and then run from there. But yeah, that was tiny easy. I can actually run through it if you guys want, like, see me do some exploitation stuff. Okay, I saw enough. I saw one head nod, so I'll try it. Let's try this nifty SCP again. Tiny easy, SCP, tech P2222. So if I were to do this in PWNTools, it'd take me a little bit longer, but I can do it. Let's go easy here. Guest, GDB, easy, start. So here we pop EAX. This looks the exact same. But since our check sec says NX is disabled, we're able to just jump straight into some shellcode that we can control. So now I kind of had to remember how to do it. So if we did vim, I wonder. So the best way to get shellcode is just to look up shellcode. Let's go x86. And boom, this guy. Don't like the new lines though.
Do you ever use Jeff to search yourself?
I have not, but I know they can do it. Is it actually?
Yeah.
All right, let's try it. GDB of, well, mostly I've been using PWNDebug recently,
Oh,
but it's had problems that I don't really like. But it also has some nice stuff, so like if I did stack, it'd just print out the stack for me, which is pretty nice. Anyways, what is the syntax for this, Jared?
okay, so you go shellcode -s search tech search, and then you just do like bin bash in line quotes, yeah.
/bin/bash, and let's go sh.
Don't do tech, just search. And then you can do get on the one that you found earlier, so it was 86 bytes.
Okay,
86 bytes. So you could just do get.
this one looks good. 132.
Because that was pretty good.
Do I need to do
Just do shellcode again,
32?
and then it'll save it.
Where does it save it to? This guy?
It shows you.
Oh, that's gross. Oh yeah.
But it,
Well, thank you. That was. You guys just got a double dose of pwning. Don't say that to anyone else. Okay. So what were we doing? So we gotta send in our shellcode. Cat, that guy. I don't actually remember the correct syntax. Let's do some Google foo. Set program to argv1. Set program not argv0. Maybe this. Oh wait, what if I just did this? I got a better idea. Let's XXD this. Whoops, XDD. XD. So this just gives me the byte codes for everything, which looks like it has a bunch of garbage, which I was not expecting to be in there. Wow. This is useful, Jared. So let's go back to this shellcode and copy that. Alright, so new idea. Totally original, but we're actually going to have to fix it a little bit. Darn it. Quit. Okay. So let's go to this nifty online x86 assembler, because we're working with, yeah, since it's EAX, it's a 32-bit program. Whoops. I need this. So what I'm actually thinking of doing is making some shell code, copy the file. No, that's not going to work. Oh, maybe it'll work. I don't think it'll work. Okay, that's a bad idea. Does anyone remember? Jared, do you remember? 'Cause I'm pretty sure this is the right way. It's to set this to a different argv.
I've never done this.
You never did this one? I could cheat and just look at a write-up, but unless I could do it with that. Oh, thank you. Might actually be able to do it with PWNTools. If I look here, go to process. Oh, right here, executable. So we might be able to specify argv and an executable, which would make our day pretty easy. So let's try that. Vim, tiny.py from pwn import everything with process. We'll have our shellcode equal to a list. So we can say argv equals our shellcode, executable equals tiny as p. P.interactive. This will give us a sh shell if it works. It did not. So, new idea. I don't think I have time to just attach GDB to it, because I think the program will run and die by then. I did. But argv shellcode. Let's test it out in just a regular test.c. So this is hacking 101. You just get stuck and you just start trying stuff. Dark C, we'll do a character pointer, argv, printf, %s, argv0. Oh, even better, we can say scanf. into argc. That's not how you scan F. We'll get char. Test.c. So now we wait for input, so our tool can actually connect to GDB if we want to walk through it. So if we check tiny again, tiny, switch this to a.out, tiny, we're now connected, finish the read, kill that, and it died. Very nice. Should not have died like that, though. Oh, because it wasn't interactive. Okay. So here, we're in our main. It looks pretty gross, but this is going to be a printf. So if we move RAX, move RAX, RDX, RAX, whatever, we can look at RDI, which is right here. This will point to our string. So if we check this, x/15i of that, we can see our shellcode's actually there. So it is working. But it did not work. So yeah. So we want that sweet shell. So what's another way? So I'm not sure why that didn't work. Oh gosh, quit. Let's get rid of that. Seg fault. Why is it seg fault? We got some bad shellcode, or copied it wrong. So let's find some different shell. Shellcode x86. This guy. 19 bytes. That seems too good to be true. It's worth a try. Copy. I'm too lazy. Code equals that. Maybe we're missing something with though. Oops. Maybe we're missing something. So pop EAX gets argc, EDX gets argv1. Oh. That would be our problem. So right here, I thought it would actually be the pointer to our shellcode, but instead it is the characters at that shellcode, so we actually have to jump somewhere else. This doesn't seem right though. So if we're calling, don't have enough. Any ideas? This might be a little too much because I'm doing the wrong file also. That would help. Not too much, but it will help.
Your tiny.py always opens tiny also.
Yeah, I just realized that. Yeah. But the problem with this is that EDX will still point to the will still be the characters at the location, not the pointer to it. So if we jumped to let's try this one more time. Kill start pop EAX, pop EDX. Move EDX, that D word. Oh yeah, there's no start. There's not gonna be. I feel like it's right there. Well, I just feel bad for like leaving you guys on so much hope when there's obviously none. So, let's do what regular people do and cheat.
So is it? Oh, you're just gonna go.
Oh, no, I didn't. What?
I think we can do it.
Oh, okay. You think we can do it?
Yeah.
All right.
So show me the characters mark V0.
So we can control EDX, but we don't know where they're going to be stored because the stack will still be different every time. Unless they're also stored by chance inside our local store. Oh, that's... Yeah. No, we don't have a local.
The fact that stack is RWX2.
Oh, it's not going to... This isn't a heap spray one, is it?
No.
I think it is.
Well, you could just put.
I think it's a stack
You could
spray.
make RV2 just a bunch of no like 90s.
Yeah, that's a heap spray, though. Those aren't fun.
Just do it.
Okay.
Then just make your RV0 address somewhere.
Okay, guys, so what I'm going to do is something I don't like because I don't think it's actually really hackery, but it's still pretty common. So if we set this to 0x90 times 0x, let's go with 4,000 characters, and do that, and then set this, let's go 1,000 times. So we'll have 1,000 arguments, each with a bunch of garbage, except for the first one. We'll change that. Code at 0 is equal to P32 of 0x7FF 400. It's a huge guess. Inappropriate nulls. Oh gosh, that's right. Doesn't like that. Bash doesn't like null bytes inside its commands. There's got to be a way to do that, though. Ah, whatever. It doesn't really matter. We can just set that to 1. Too many arguments. Okay, let's try that less. 500. Too many arguments. 100. Nope, didn't work. Let's try it again. Nope. So this is a heap spraying, is that we just keep trying until it actually works. Because if we look at the heap, which I can't really do, but if I were to GDB tiny, I'm still using the wrong tiny too, aren't I? Yep. Underscore easy. Okay, well anyways, GB tiny easy. So what heap spraying is that if we went to this address, oh, I wasn't even close. Alright, so we went to this address, this is argv. So what we're pretty much doing is then spamming this like hundreds of thousands of times with our own shellcode so that hopefully we guess correctly and jump straight into our shellcode. And then we'll use these 0x90s, which are NOPs, to just float straight down to the command we want. So let's replace that with an F. Oops. Tiny. Here. We'll also do a while true. True is not defined, but sure is. So yeah, this is heap spraying. Let's try a different address. Okay, gotta kill that differently. Python kill 2570. This is too high. Oh yeah. It's gonna be at the bottom of the stack, so I'm not sure I'm putting the tab. That looks better. Oops. Just maybe one of these times. But maybe not. Okay, so we would do that for like an hour. Let's cheat. Because I don't think that's right. What? No way.
That's exactly. Just make your no-ops operator and then don't do that.
No. I think they have. Because they have a hard-coded. I mean, so do we, but they weren't heap spraying it, were they?
The second one was.
Oh, yeah. That's a huge
Oh,
heap
yeah.
spray. All right. So, yeah. Everyone's heap spraying. So, let's increase that.
Change it to one arc, but then make the.
25952. So that's a little bit bigger. I'm still going to keep it at 100 though. Never mind. Fingers crossed. So yeah, this is why I don't like heap spraying, is because you can't actually get it every time. But it is possible sometimes. Let's copy their address too. They're going with the C0? What are these guys going with? They're going with the one. Oh, they're going even lower. This guy's FF still. Wow. Environment. Oh, they did 21. So I guess just keep increasing it. Times 21. Okay, times 10. Times 5. Okay, never mind. I won't use that at all. Guess all we can do is keep going. Just like flipping through these so fast that one team's gonna hit it, but then just skip through it.
It would stay in the shovel.
You're right, it would. So let's just spam it even faster. Would it? I don't think it would.
It would.
I don't think it would.
Why not?
That looks like something. Because I think since I'm using PWNTools, it won't.
Yeah, but
26308. Okay, I got an idea. So let's get rid of this interactive and just say p.sendLine. We'll do an ls. And then p.interactive. So this will only work because this send line will kind of crash the program if it's dead. So let's just toss this bad boy into a big giant try. And accept is pass. So now this will only work when it works. Boom! Oh wait, what? That's not right. Darn it! Why is it doing that? So excited. We're using this the right file, aren't we? Yeah, tiny easy. I wonder if it's like a my system problem.
well, your environment list will be way longer than their system.
No, it's like the environment should be the same, or the list, the
It's not like-
argv should be the same. But I'm wondering if like they have something else set up.
Yeah, like I'm saying their stack will be way different because their environment's.
Yeah, so let's just try running on theirs.
Yeah, just copy their code and then run it on theirs. Okay.
No, our code is perfect. Oh. 27576. As you can see, it was pretty efficient at its time, though. Oh yeah. Kind of lazy, so I'm just gonna copy it by hand. Oh, just wait. Tiny pi. Let's switch this to home/tiny _ easy. What's this user's name? Yep, tiny easy. So that should work. WQ cat tiny .py. Copy that. Go SSH tiny _ easy. Guest temp vim easy.py. Oh, look at that, we're the only ones. That's not cool. I don't know if any of those worked. I think I killed it before we even got to it. I don't think it's something with my code. Try theirs. Oh, this is all inline too. Be even better. Oh gosh. I can't kill that though.
You said your P32 is only 7 characters. You need another app.
No, is that it?
Yeah.
Oh my gosh. That's embarrassing. Yep. So let's try that. Gosh darn it. What? What is that?
That's a sort of fun crash.
Let's not worry about that right now. Grep for Python. Python. Kills. Oh my gosh, look how close those two are. That makes sense though. And tiny. Oh, you're gonna miss the best part. It actually working. Maybe not though. Oh, there we go.
Nope. No, it's
Did it?
still-
Good call. Huh. Let's try going to a smaller stack address. Let's put that as a 0. Gotta kill that now. Let's just pgrep for Python 7072. Okay, let's use someone else's shellcode. Let's pgrep kill that 13792. Import, oh gosh, gotta make this all Python too. Oh, as you can see, I also lost my cursor. So that's better. So let's do some inline Python. Oh gosh, let's put those double quotes. Segmentation faults. Let's do while true, do that, done. Wait. Oh, I did mess something up.
Extra single quote.
Oh, there's an ls right there. So this gives me hope. Not much. Oh, what was that? Test. It worked! That's how it's done. Any questions? So, if we look at their shellcode, they're obviously just reading the file instead of... Not sure what all that is, though. Huh. Is that just like Python stuff? Oh, it's like
That's
splitting.
what the X character.
Here, let's copy this guy's instead. Don't worry, this is going to be... Will this work? Let's try it. I feel like this is a bad idea. Who am I? Boom, root. Oh gosh. Okay, so if we clearly just use our code that we created just now and just use that as an SSH, yes. Boom. Oh, that is slow. It's going to take forever. So any questions? As you can see, this is kind of why I hate heap spraying. I think it's kind of evident. Okay, so let's try and think of the next one. How do we do this on the hard version? We don't have NX, so we can't just heap spray. There's got to be something we're missing.
Someone wants to know which is worse, heap spraying or Patriots fans.
Ooh. Anyone here a Patriot fan? No? Yeah, no? Okay. Heap spraying. Look at that baby go. But yeah, in like a day or two, we'll get the flag. So that's all I got. I guess this last part wasn't really PWNTools anymore because it started using OS. But what? Huh. So apparently os.execv doesn't set tiny to... Oh my gosh, we got it! Look at that! There we go. Boom! What a tiny task. Easy. Oh, but apparently os.execv also does not set tinyv to, or tinyEZ to argv0, which is pretty cool to know. But yeah, go use that knowledge for something that's actually useful. Oh yeah, that's it.